Question 1. The graph shows the variation with the time t of the horizontal force F exerted on a tennis ball by a racket. The tennis ball was stationary at the instant when it was hit. The mass of the tennis ball is 5.8 into 10 to the power of negative 2 kilogram. The area on the curve is 0.84 Newton per second. Calculate the speed of the ball as it leaves the racket. So to solve this question, we first need to know that impulse is equal to mass into the final velocity minus mass into the initial velocity. Now in this question we have not been given a second mass or another speed, so we can simply cancel this part out. So we will only need this part. So the impulse over here, so we are searching for the speed. So if you rearrange the formula, we will have the velocity is equal to impulse over mass. So the impulse is equal to 0.84, as this is a force time graph. When you find the area under the curve, you'll get 0.84. So the value is already given here. We can input the value in place of impulse, and then there's the mass. The mass is given here, 5.8 into 10 to the power of negative 2. Input that in place of m, and you will receive 14.5 meter per second. And that's how you solve that's how you solve 1A. As for 1B, show that the average force exerted on the ball by the racket is about 15 newtons. First of all, the formula we will use is force is equal to delta P divided by delta T. So you can look over here. Delta P is equal to force into time. So we already know what this value is, 0.84. So you can input 0.84. And to find the time, if you come to the graph here, if you look at this point here, this will be 28, and this point here will be 12. So when you subtract 28 from 12 and multiply that into 10 to the power of negative 3, you will receive 16 into 10 to the power of negative 3. So that is the time. So when you divide the two values we just got, you'll receive 53 newtons, and when you round the value off, you'll have 50 newtons. And that's how you solve 1B. Question C. Determine with reference to the work done by the average force, the horizontal distance traveled by the ball. It was in contact with the racket. So to solve this question, we'll use this equation here. So where the work done is equal to force into displacement. So delta x is equal to displacement here. So since we're supposed to find the distance traveled by the ball, we will rearrange the formula for delta x. So displacement will be equal to work done over the force. And now we will use another equation here. So this is the kinetic energy is equal to half times the mass into the velocity squared. So we already have the values for this from the previous question. So you'll have half times 5.8 into 10 to the power of negative 2. This was the mass given in the question. And multiply that by 14.5 squared, which was the answer we got for part A of the question. That's the velocity. And now we have this here, where the kinetic energy is equal to the work done. So if the kinetic energy is equal to the work done, you'll have delta x. You will replace this full thing here is the formula for the kinetic energy. So input this over here, and below the work done there's the F, and the F is equal to 53, and this we got from part B of the question. So when you simply equate these two values, you will receive 0.12 meter as the answer, and that is how you solve part C. As of part D, draw a graph to show the variation with t of the horizontal speed v of the ball while it was in contact with the racket. Numbers are not required on the axis. So to draw a graph, so this is what the graph will look like. So you can see with time the speed is sort of increasing, and then it started like uh, so at this point here, um, the ball and rocket come in contact. Therefore, there is a very the speed over here is increasing very fast within less time, and yeah, then the ball slowly slows down. So this is the graph that you will receive. And yeah, that's how you solve question 1 for this paper.